So aldehydes and ketones are basically differentiated based on their reactions with a mild oxidizing agent. So in this video so there are two tests that we'll be learning about, Tollen's test and Fehling's test. And in this video we are going to be talking about Tollen's test. The reagent used is the ammonical silver nitrate. So ammonical silver nitrate is formed by mixing up ammonium hydroxide and silver nitrate. So much, and this is mixed till to the extent where a precipitate of AgO, silver oxide, is formed and gets dissolved immediately. So aldehydes give a positive test when they react with the Tollen's reagent. So the reaction is RCHO, that is an aldehyde, is reacting with 2AgNH3. This is the ammonical silver nitrate, AgNH3 taken twice, plus 3OH minus to give rise to RCOO minus plus 2Ag plus 2H2O plus 4NH3. So here in this reaction, what is happening is the aldehyde is reacting with ammonical silver nitrate to give or to undergo oxidation to form the carboxylate ion. And because it is undergoing oxidation, the silver which is formed over here, you can see, right? It will give a silver mirror. So assuming this is a test tube, so there will be a silver mirror on the inner wall of the test tube, and that is how we'll know that that particular compound has an aldehyde group. So here what is happening? This is giving us a silver mirror because aldehyde underwent oxidation to form the carboxylate ion. And so the aromatic as well as the aliphatic aldehydes will give a positive reaction to Tollen's test, whereas ketones do not give positive for Tollen's test. The other one that that we learn about is the Fehling's test. And I decided we might as well do it in one video. So Fehling's test consists of two solutions. Okay, first the Fehling's test consists of solution A, Fehling's A, right there, and Fehling's B. So Fehling's A and Fehling's B. So before the test is done, what they do is they mix equal quantities of Fehling's A and Fehling's B. So Fehling's A consists of aqueous copper sulfate, okay, whereas Fehling's solution B consists of alkaline sodium potassium tartarate. Alkaline sodium potassium tartarate, and this is called as Rochelle's salt. So Fehling's test has two solutions, Fehling's A solution A and Fehling's solution B. Fehling's solution A consists of aqueous copper sulfate, whereas Fehling's solution B consists of alkaline sodium potassium tartarate, which is also known as Rochelle's salt. So basically before the test is performed, equal quantities of A and B are mixed. So aldehyde is heated with the Fehling's solution, and basically, okay, so RCHO is the aldehyde, and in the Fehling's solution we have copper ions and we have OH minus ions as well, right? So basically what happens is it leads to the formation, obviously the aldehyde is going to undergo oxidation to form a carboxylate ion and copper oxide. So this cuprous oxide Cu2O's, cuprous oxide, and it gives a reddish brown precipitate. And we have water. So RCHO, that's the aldehyde, is undergoing the reaction with Fehling solution A, equal quantity of Fehling solution A and B, to give rise to the carboxylate ion. Because it is undergoing oxidation, we have the formation of cuprous oxide, which gives a reddish brown precipitate. So aldehydes are heated with the Fehling solution and they form a reddish brown precipitate of the cuprous oxide. And this particular test, Tollen's test, was given by both aromatic as well as aliphatic aldehydes, whereas Fehling's test, on the other hand, is given only by the aliphatic aldehydes. They are not given by aromatic aldehydes. So aromatic aldehydes do not give a reddish brown precipitate. Both of them are not given by ketones. So to recap, Tollen's reagent, Tollen's test, the reagent used is ammonical silver nitrate, which is denoted by the formula AgNH3 taken twice complex plus 3OH minus. So the aldehyde is undergoing a oxidation reaction with the Tollen's reagent to lead to the formation of the corresponding carboxylate ion. The silver, which basically separated out, gives a silver mirror on the inner side of the test tube. The Fehling's test consists of two solutions, Fehling solution A as well as Fehling solution B. Fehling solution A is aqueous copper sulfate, whereas Fehling solution B is alkaline sodium potassium tartarate. So here also the aldehyde is going to undergo oxidation to give the corresponding carboxylate ion, but here there is a formation of a cuprous oxide and this gives a reddish brown precipitate. This test is given by aromatic as well as aliphatic aldehydes, whereas this is just given by aliphatic but not by aromatic aldehydes. With that, we're done with this particular ways of differentiation of ketones and aldehydes. In the next video, we'll be discussing about aldol and cross-aldol condensation.